people gonna be talking like the
accelerator, like an actual chip, and also demonstrating that we could actually run real-time speech recognition and machine translation on the edge device. So our goal as a company, what we're trying to do is to empower businesses and consumers to create their own custom personalized AI, and we do so by providing a product that packages latest research in AI and computer systems. And I also actually was involved with two other startups before starting this company. And one of them could be actually more relevant to this audience, primarily because that company was focused on a medical application. I had started a company with radiologists from MGH and also Penn to build a patient-focused medical image sharing platform, of cloud sharing platform. And we were able to actually sell that company to another company building similar kind of products. But that was like a really good learning experience as well, because there are also additional challenges when it comes to building a company in the healthcare space with all the regulations and etc. So I will start by talking about large language models. I'm sure some of you are really familiar with it, but for those who are not too familiar with large language models are essentially what is powering services like ChatGPT or Anthropic's Claude. I'm sure most of you have at least like seen it or used it, but these models are basically models that allow you to understand and generate text. And the way you train these models is by feeding it very, very large amount of textual data. And the beauty of this is the fact that like now this technology enables us to read, or the computers and the machines to read, write, and answer questions like in a very human-like language. And the how they work is actually somewhat important because they work by predicting the most probable next word. So for example, if you look at the sentence, better late than something, basically it's going to guess what would be the most probable word for that next word and then pick the most probable word. So when you train these models with a very, very large volumes of textual data, it's going to learn from all of these data to kind of create this semantic understanding between the words and between the sentences, between the paragraphs, to basically answer any of your queries. So if your query is, hey, complete the sentence, it's gonna be doing this. But even if it's just like a question, it's going to then think about, oh, what is the most probable answer? And then start predicting it by token or word by word to produce a full response. But I'm going to talk about like some of the downsides, and this comes from more of like my academic research, right? Like when you look at these models are known to require thousands of GPUs to train them. So you guys probably might have seen some news on the press how they're raising billions of dollars because they need to buy 50,000 GPUs to train these models. And we have multiple of these startups or like large companies that are training these models. But, you know, so one thing is the cost, right? And I think it has become a pretty big problem for the academics who are doing research in this field, because us as academics, we don't have resources like thousands of GPUs. So one thing is the financial cost. And then the second, obviously, is the carbon emissions that comes from training all these really, really large models. And a single large language model's carbon footprint can match the life emissions of five cars. And I think this is going to grow as you build larger and larger models. And also, like, one thing about these large models is that they're very general. So you're basically training them on a lot of the public data. So while it's going to be an expert on the data that it was trained on, it may not know the knowledge of some proprietary data that may sit inside a private organization. And also because it doesn't have a focus, it may actually fall short compared to a more domain-specific models. For example, like models that were trained primarily for healthcare or biotechnology or finance, and etc. So part of my research has been really focusing on increasing the efficiency of these large language models when it comes to training these models, also deploying these models in practice, and also basically allowing each of the use cases to be better handled through personalization or specialization of these models. And this is quite important because, like, as you know, I've talked about how resource hungry these models are, but it has been proven over time in different examples that we don't actually need models that are several hundred billion parameter models for most of the use cases. For example, if you really focus on a specific domain, you may be able to train a model that is much, much smaller, much faster, more efficient, and it still outperform the really big models. For example, we trained a financial model focused on just financial data and the financial Q&A and all the financial natural language processing tasks. And we were able to actually outperform GPT-4 by a significant margin, like 20%, just on the financial tasks. And the model size was 20th of the size of these big GPT-4 models. So you could easily see that when it comes to practical usage of these models, you may want to build smaller, faster, and more efficient models. So some of the research that I've done have been primarily focused on doing so. Like we have papers on latency optimization, basically making sure that like the responses come out really, really fast. And this is going to be increasingly important because now like people are okay with certain latency when you're on, typing away on ChatGPT, right? But as you imagine, when you go from just the asking questions and receiving responses to what is in the future, what people are imagining is now having these AI being able to handle human conversations. So when you imagine like customer support, for example, right now, sure, like you could have like these clunky chatbots that fail most of the time. But what people want to eventually do is to have an AI that could actually have a realistic conversation, as if you're talking to a human customer support agent. And in order to enable that, you got to make sure that there are no awkward pauses and delays between what you're saying versus what the AI is saying. And I'm sure like you guys all have experienced the current generation where they're like, oh, why are you calling us? And you say refund, and then it'll just pause for like a couple of seconds. Okay, so you said refund. Okay, let me handle your refund case. So like the goal is to basically focus on making the models perform better and better while making sure that models run fast. And also the fast fine-tuning of large language models. As I mentioned, this fast fine-tuning also tackles not only the speed in which you train these models, but the efficiency of the compute. So for example, you use quantized large language models. So the models are generally smaller, it requires less number of computations. And also at the same time, we have came up with algorithms to correct the errors that may be accumulating through these optimizations to make sure that the accuracy is actually stay the same while you're doing all these optimizations. And the benefit from this is that you could now reduce the number of computations, therefore the carbon footprint, and also at the same time, you get the fine-tuned models really, really fast, and you could do more frequent iterations and updates. This is also like proven to be useful for finance in particular, because the new information that is being generated, all these like financial news events that are happening, is highly important. Like it's very, very important for financial tasks. So frequent update to the models themselves are quite important in maintaining a very high performance. Whereas like if you look at models like ChatGPT and other big models, you would see the data cutoff point being like maybe 4 months ago or something, because it takes a lot of resources to even update these models. Last thing is the throughput. This is also related to the usage of these models, right? How do we use this less number of GPUs to handle more queries? And obviously, all of these things are very actively being researched by not only us here, but all the other universities across the world. So what we have built is a product called XChat, which is an AI agents platform, and our focus has been automating the decision making and task execution. What I mean by decision making and task execution is that the prior implementation of AI assistants or co-pilots tend to be not autonomous at all. You tell them that, hey, I would like to get an answer for this question. It will give you the answer. I would like to summarize this. It would summarize it. But now, with the enhanced capabilities of these models to reason, you could have these models behave more and more like actual humans, including the decision making. So like when you see an email, can this model decide whether to reply to it automatically, or can it decide to refer it to a human? And if we were to use that phone call example of conversational AI being used in customer support use case, like this is very important because like prior implementation of all the chatbots used to be very rule-based. So you would have to define the rules and build out these massive decision tree to handle all these different situations, which is why it was so clunky. But now you have an AI that could actually have a conversation like human, except that like when it comes to making decisions based on what the customer is saying, it is important for these AI to learn how to make decisions, correct decisions, but also learn the preference of the creator of these AI to make sure that these AI agents would behave exactly the way you want them to behave. And in order to do that, we have built like three things. We have a domain-specific automation agent, which is trained on specific domains like healthcare, finance, and whatnot, as a good starting point to build off of these agents to before you do any sort of like personalization and specialization. And then we use evolutionary algorithms to make the process of evolving these models really easy. So challenges that there are not that many people who are capable or who are very familiar with training these large language models, but the potential of these models is great. So how do we then allow these models to autonomously update themselves based on how the users are using it? Like there could be different questions and different distribution of queries over different times. For example, I kept using the financial example, but based on certain events, like, you could see an uptick in users talking about, the NVIDIA killing it in the stock market, how, AI GPUs are short in the market. And basically, then the AI would improve based on those queries and also based on the feedback that people give to these AI model. And the last, yes, go ahead.
We have a question in the chat. Tyrone, if you want to ask a question.
Very quickly, what do you mean by agents? Are these actual models that are talking to each other, or are these system prompts that you're putting into an LLM?
So yeah, I should have defined what the AI agents are. So AI agents, the key difference between what you would describe as AI assistants and AI or co-pilots, between those versus like the AI agents can carry things autonomously. So for example, if you were to say, oh, can you go to my customer relationship management platform like Zendesk or Salesforce and grab a ticket from it and see if you can answer these questions, access appropriate knowledge bases to fetch the answers yourself, and can you generate a response for this customer's query? Typically, if you're using AI assistant, humans would actually be telling the AI assistant to say, hey, can you do this? Can you do that? But then, one thing that is not mentioned here is the subtle decision making that happens, right? Like, how does the AI actually know how to answer this question or not? And these are all actually decisions that are made by AI autonomously. And that's what the biggest traits of an AI agent. Does that answer your question?
Yes, I would then follow up with, I don't really know its decision making, but I also know that if it's just text, how is it getting a ticket? How does it interact with the Salesforce UI to receive that ticket? Is it going through an API?
Yes. So typically you would need to provide tools that these AI agents could use to access external databases or external API or software programs. And obviously that is, obviously that is what our tool provides as well, right? We provide integration with commonly used tools for customer support, for example, like Zendesk, Salesforce, but also at the same time, we also support integration to Google Drive, Gmail, Notion, Confluence, Slack, Discord, a lot of the commonly used software to give the agents the ability to access these software tools. We don't do this, but technically you could have a AI agent that specializes in software engineering, and you could basically tell the AI agent to say, hey, I want to integrate with Zendesk. Can you write an integration with the Zendesk API based on this API documentation on their website? And the AI agent would also be able to do that. And part of this is actually the fact that like the AI agents are go through different stages of doing it. Like one of the most important stages, planning stage, where the AI thinks about, oh, what do I need to do to build this integration? Oh, maybe I should first learn from the documentation webpage. 2, generate a code. 3, try running the code, see if there are any bugs. If there is a bug, 4, try to debug. And how do these agents debug the code? It could actually do things like access the internet, go to Stack Overflow, search for that bug, and then basically go back to the code that it has written, fix it, iterate until it is fixed. So there is that reflection stage as well. Planning, reflection, the actual execution, and being able to iterate all of that autonomously is how you would build such agent.
That's in real time?
Yeah, you could do that real time.
All those steps in real time, including planning, learning, reading through the API docs. That's all done in real time within realistic.
We should go ahead with a talk.
Yeah, sure. Yeah, and I'll just go through some of the case studies, and I could actually give you a demo too. But basically, we have leveraged our product to provide customer support improvement to a company called Thor Industries, which is a Fortune 500 recreational vehicle manufacturer. It's the largest of the world, pretty much a monopoly at this point. And for them, their customer support agents have to deal with hundreds of different models. And, all these they might have different parts. And because it's an RV, it's not just the car, but also like they have a lot of home appliances. So what if like the customer were to ask, oh, my AC broke. And then, like obviously you would want to know which model it is, what year it was made. And all of this requires an intense amount of like digging through different documentations to find out where that information is. So it takes a very long time. For this particular company, their average response time was 24 hours, which meant that like a lot of time had been wasted just trying to find information to actually resolve this customer query. And part of the time it takes is not just like searching for the information, but also if you cannot answer the question, even after you search through it, how do you then escalate this ticket? Like who do you escalate it to? And a lot of this is can be automated through the use of agents as long as you could teach these agents to make the correct decisions. And so with this company, we were able to improve the customer support use case by allowing our agents to handle 100x more tickets per day. So from 24 hours, like typically it takes like less than 10 minutes to handle a single ticket autonomously with 99% accuracy as of now. And if you look at the left side of the screen here, this is like how you would build an example intelligent workflow that could automate decisions and actions. So I'm not sure if this has high enough resolution, but you can see that first step. And this is what you would see when you tell the agent to, hey, can you take a Zendesk ticket and answer this, refer to knowledge base if needed, and try to come up with a plan and try it on a ticket, like it would then come up with the plan as shown. It came up with 5 different steps: fetching the ticket, searching the knowledge base, generating a response, reflecting the response, and then saving a draft inside Zendesk so the agent could log into Zendesk and see all the drafts generated automatically. And you could basically do this across like multiple tickets too. You could say, oh, can you run this across all of the unresolved tickets on Zendesk? And it would go out there and do it. And I think that's where the huge value add is, because now you are able to just automate a lot of the mundane task of searching and doing these things, and you just have to confirm the what the AI has created. And obviously, as long as the accuracy is high, you could potentially get to a point where you just send it out without even verifying the results, right? And the second part is where how we apply the human feedback. So we said that the decision making is important, but other than also decision making, there are also some things like style, tone, how you want to talk to your customers. So for example, like for this, basically the AI had looked at the drafting the response part. So it fetched the results from the knowledge base, and then the result, the answer to the question, how much does the special edition of your RV cost, with a specific cost with a citation. But you actually wanted it to be more friendly towards the customer because this is the actual response being sent to the customer. So maybe you add some fillers like, thank you for your interest, blah, blah, blah. And then after you directly edit these responses, AI would learn your preference to add these sort of like fillers to make it seem more polite. And this happens autonomously behind the scenes. And this is the other part of providing feedback. You could actually do that during the planning phase and going through your workflows, but you could also do it ad hoc. So for example, you could just ask a question and then basically give a feedback, thumbs up, thumbs down, or provide like more additional like in-depth feedback, such as like, is it accurate? Is it inaccurate? Provide some sort of explanation. And once you could also suggest like correct answers. And once you provide these feedback, you'll be able to collect that and then basically apply it to the AI to improve based on this feedback as well. I will now show you a quick demo. So this is the chat AI with the chat interface that we have provided to one of our customers called Airstream. And basically, you could see different versions that we have created. You can create a new space by clicking a new space and typing in something, and then you could create it. You could also upload files from your computer. You could also add website links. You could also import stuff from other places. And when you do so, you'll be able to see all of the files that you have imported. As you can see on this page, you can see all of these documents that they have imported into the system. And you could also see some of the feedback that has been provided by the actual agents. You can see that like some of these are all like negative, some of them are positive. And you can also do additional integration with external software. And you could also generate like and use multiple different models, versions as well. But this is actually like a developer access. So for the actual customers, they don't have like the selection of different models but for us, like we wanted to add that for our research purposes. You could also share these models to other people. You could see that like here, we have multiple different admins. We also have an editor, and you could also just invite it to viewers. Viewers only have access to the chatbot. They cannot modify the knowledge base, whereas like the admins can, and the editors will be able to do so. You can also look at this and copy this link. you could actually access it externally using this window, and then you could just type in stuff to do it. But this is more useful if you're actually trying to embed the chatbot into like a web page. So for example, here we have the code that you could copy paste and include on your website. And on a Harvard system, Grid has our chatbot here. And this is basically a chatbot that has been trained on their website. And you could actually chat with the website to basically, have search through the information that is on the website. And you could also see all of the chats that have been done by different members that were improved. And this is more of an admin feature because you might want to see, what are the customer conversations that have actually happened and which of the agents have said what to their customer, and you could delete them. And so that's the general usage of this AI thing. It seems very simple, right? And I think the goal is to make it so that like it's easy for you. Yes, did you have a question?
Yeah, I was just curious, what is the average inference cost for the company?
So for us in particular, so for our customers.
For your customers, yes.
So right now we had not been doing usage-based pricing, but we had been just doing it per seat, right? So our inference cost compared to using a model like GPT-4, for example, we're able to provide per inference like maybe 10% of the cost that it would take to run GPT-4 models. So this is quite important because like a lot of the products out there that have been built on top of GPT-4 have not been in mass production yet, meaning that, they're probably serving maybe 10, 20 users. So the cost of inference is not really high. But when we started the company like 2 years ago, we had initially started working with companies to help them move away from GPT-3 or 4. And these are the companies that actually had products in production like Jasper AI, which is like a marketing content generating company. And these companies suffered a lot from low margins. Like the numbers I had heard from the rumors is like 30% margin, which is ridiculous for software companies because software companies usually operate at margins between worst case 60% to 90% margin. So, I think we're going to, a lot of the companies and products that have been built on GPT-4 is going to suffer, at least in the short term, from like expensive costs. And we're going to definitely see a lot of different production applications built on these smaller models, whether they're like your own proprietary small models or just open source models that are readily available. And I think Meta is supposed to open source their Llama 3, which is their latest version, which is built with the objective of being on par with GPT-4 or even better. So like I haven't tested it myself, but I've been hearing from my friends that is actually, looks good so far. But
it's already out?
It's already in private preview for the Meta employees. And I think they're going to do it in like next week or so.
Oh, interesting.
Yeah. But I don't think they're going to do it all together. They're going to start releasing the smaller ones first and then the larger ones later. Did that answer your question? So I could actually demo if I have time later, I could also demo the AI agent stuff. But so for the personal features, so what we have found through the experience of working with these multiple different use cases in the enterprise was that a lot of the building blocks for these agents involve common natural language processing tasks, whether it's like summarization, whether it's generating some email responses or whatnot, and then leveraging all these like building blocks and tools, as I mentioned, access to Gmail, access to Google Drive, Calendar, and whatnot. We're able to like build out some use cases that are focused more for the personal use cases like email retrieval, and then basically automatically generating drafts. And also we have other web search agents in which you could generate or do a research, let the AI agent do the research for you. So things like oh, can you give me top 3 restaurants around the Longwood campus? It would be searching the internet for the best candidates. It will compile a list. Maybe it's going to go through each of the lists to see if it is actually a valid information, and then basically reason on its own to figure out what are the top 3 on its own. And I think the potential application that we had been initially building this for was primarily like in the financial institutions. But we've also seen that it is commonly applicable to like marketing, doing competitive market research and whatnot. Like if you're building a certain product, hey, can you find all these competing products that are out there and then generate a report for me? Give me a summary of all the differentiation between our product and their product, and organize it in an Excel sheet, and give me the link to the Google Drive that contains the Excel sheet. So these are some of the things that we have built. We're actually going to integrate a lot of these new features into what we call a community version that we plan on providing initially to the Harvard community first for free. So you would be able to, if you're using your Harvard email, just use this service for free. I think this is like one way of us like trying to contribute back to the Harvard community, because we actually got so much support from Harvard and the community when we were building this product. So this is more related to like the personal story of like what I found to be challenging, and because I come from although I've done the startups a couple of times, like I think it was still challenging as an academic to work on non-technical stuff, right? Including like user experience, thinking about how to make it easy for these agents without technical knowledge or anything. They may not even know what an LLM is, but building something that they could easily use. And also doing sales, talking to customers and companies. So one of the things that helped me a lot with sales and the customer support was I had gone through a program called it's a National Science Foundation program called iCorps, and they basically force you to do customer discovery, like 100 calls in a span of like a month or two, and that sort of like forced us to go out there, talk to these companies, or so-called get out of the lab. And that was really helpful, because I think through that, we were able to actually talk to a lot of companies to feel their pain points and actually understand, instead of building a hammer and finding the nails, like the gist of the program is to actually just take a step back, talk to the customers first, and then see if there is any connection between your technology and whatnot. So I think that could be helpful, trying to figure out like which of your research is more commercializable compared to the others. And obviously there are other challenges like legal contracts and whatnot. Even if you were to use a lawyer, I think you need to have some understanding of like the basic things that you should watch out. And when you're doing the contracts with other companies, like starting from, the NDAs, but also more specific on how the IP sharing and all that stuff is going to happen. Fundraising was also like, a very new thing for me. And then of course, like hiring, HR, culture, building culture. And I think these were all some of the new things that I've learned. I'd be happy to talk to anyone and share my experiences outside of this call if you reach out to me. And as I mentioned, I got so much from the Harvard community. First, now it's called Harvard Grid, but Harvard Grid used to have a thing called Physical Sciences and Engineering Accelerator Award. I think now they have expanded it to not just the engineering, but other fields too. Basically gave me like a grant that allowed me to use the grant money to take my own time off of research and just explore commercialization. I forgot how much they're providing right now. I think it's somewhere between 100K to 150K, which is like not a bad amount. It's just grant money, so there's no equity involved. And for a lot of the researchers, it gives them the resources to actually like travel, talk to more companies in person, attend conferences, expos to kind of figure out and do your own discovery. And obviously Harvard Innovation Labs, they provide the space and also the resources, connection with a lot of the experts that are local or from the Harvard community. And they have like multiple different competitions. We were fortunate enough to win one of them last year, but I think there's one with the business school too, and I think there's like one focused on biotechnology, biomedical technology. There's like a fellowship focused on that as well. So I think leveraging these resources have been really helpful for us. So as I mentioned, we're going to actually provide our service to the Harvard community for free. You would be able to just sign up on the wait list, and we'll provide, if you write down your Harvard email, you'd be getting access to our platform. And we'd love to get your feedback. As I mentioned, this new community version is very new, and I would love to get more feedback so that like we could improve this product to cover, provide it to maybe additional communities outside of Harvard as well. And we're also hiring full-time and interns. So if you're interested in AI, feel free to reach out. Thank you. Yes.
So you're talking about transitioning from a more academic role to the industry, and it seems like some of these things where you worked on these as an academic. So when you transitioned out of academia and went to form your own company, because these were developed when you were at Harvard, I think there are some IP connection with Harvard. Just curious how that works, how that transition went, and
right. So I think there are. So we actually through the Harvard Grids program, we had submitted a patent. But one thing about the AI is that it moves really, really fast. So by the time like we had started the company, our patent wasn't as useful, but I think there's still like pros and cons with this, right? Like for example, especially, and I think this applies especially for biotechnology. If you have a patent through Harvard, it actually helps you a lot when you're raising money. Like the VCs are going to look at your IP and they're going to look at, oh, wow, you have an IP, great, like more trust compared to just filing patents on your own. Lawyers might actually tell you differently. Lawyers could be like, oh, just wait until like, don't do anything at Harvard. Just like if this is like what you want to start your company with, come out and start a company and then like, work on that. But I think especially in particular for biotechnology, I've been told by my friends who have started the company too, that they actually think it's better to just file a patent. And Harvard actually doesn't try to take a lot away from you. Harvard is actually one of the friendlier schools when it comes to what they want from you. They also want this IP to be used in general. So they're going to give you very favorable terms. They're not going to try to steal all of your IP and just, because like in the end, in order for these IPs to be meaningful to Harvard as well, this has to be a product. So they don't want to burden the companies with very negative terms. So I would recommend that you always like, if you can patent it through Harvard, like don't think that it's going to be something negative. I think you should always do so.
Thank you very much. Are there any more questions in the chat? Oh, there's one raised hand.
I think there's one more from Tyrell.
Yeah, okay.
It's not anything related to the infrastructure. I'm pretty sure I can email you a bunch of annoying questions, but currently in recent weeks, Inflection AI largely closed stop. Stability AI is struggling. In Boston, an LLM autonomous-based research company named Ghost recently went liquidated. Do you see any signs in the industry, concerns that this might be slowing down? I know you're very recent right there, but a lot of different. It's because I don't think the boom is quite over, but do you have any concerns going forward? How do you provide more of that value coming into this?
Right. So I think you raised a very good point, because when ChatGPT came out in particular, or even before that, as people were starting to see some concrete results coming out of these models and its ability to generate text or images, like I think people that just created a lot of FOMO, and all these investors started like throwing money at these companies, right? Stability also raised a ton of money. Inflection raised a ton of money. But problem is, as I mentioned earlier in the slides, training these models is really, really expensive. And I don't think any of these companies actually were able to train something that could top GPT-4. These companies actually never really had a product. They were mostly just training models and providing them as APIs. So when it comes to investors as well, like investors, VCs have actually, I think many VCs are more aware of these issues, and they're now focusing more on the revenue as well. Like, does this company actually have a product? Like, is it going to generate revenue? Who's going to buy it? Is it actually providing business value to their customers? So compared to maybe like a couple of years ago and even last year, this year, definitely the sentiment around AI is more cautious. I mean, of course, like stellar teams could still raise a lot of money, but it's still going to be questionable whether like they're going to build a successful product or not, right? So I think the investors have definitely gotten more careful with that. And for us as well, like because we had been, working as an academic, and even after we started the company with some of the earlier stage AI companies and saw their challenges when it came to being profitable. I mentioned, companies like Jasper or like, these companies that have existed before ChatGPT. We already knew that like building a profitable AI business is actually very difficult, especially if you depend on these third-party APIs, or if your model is really big and if your cost is really big, because in the end, you need to find someone who's going to pay for the services. And although like people have now gotten used to the notion of paying extra for generative AI applications, because people talk about how expensive it is all the time, and now like I think people are willing to pay a slight bit of a premium. It is still considered a software product in the end, and it is still a customer support product if it's used for customer support or marketing or like equity research or whatnot. So like if your cost is enormous, you're not going to actually build a scalable product, and you're just gonna die out. So I think that's quite important to consider at an early stage as well.
Very nice. Also, is RAG the future of LLMs? A lot of people are trying to use RAG to fix a hallucination problem. You present training as one. You're big on LoRa's. Do you see that scaling as well as RAG, or do you see a time where I can see a future where we can have a RAG for every user? You see, right now I see your use case as you have a LoRa for each business or each knowledge base. Do you see ever scaling to the point where we can have inference training to have a LoRa for every user?
Yeah, that's pretty much our goal. But to comment a bit more on RAG, for those of you who are not familiar with RAG, it's retrieval augmented generation. So basically what it does is that it allows you to take external sources of information like documents and basically create vector embeddings of these documents, so that like when a user asks a question, it's gonna find the closest match and then just pull that information from the database and then use the large language model to formulate a response based on that information. So it has been really popular for people who wanna just use like large language models without like modifying it and connect it with some external data sources. And we actually also do use RAG as well. So I think to build the best product, you would have to use RAG, you would have to fine tune the models, you would have to do everything. And that has been our experience. So I don't think it's going to be RAG versus fine tuning, RAG versus large context size. I think using all of that together is, based on our experience, has given us the best response. And RAG in particular is only useful for retrieval, as you could guess from the name of the system or the methodology. Whereas like a lot of the stuff like generating, that's not really going to benefit a lot from using RAGs, and so much of the LLM usage besides just retrieving information and answering question, is actually doing something more creative, generating new content, or aggregating multiple different data sources and basically merging them together and generating. So like I think the answer is that like you would want to use everything. And RAG at the moment is pretty much commoditized now. There are a lot of open source RAG systems that you could just clone from GitHub and start using right away. Of course, like building a good RAG is still a different story. Like because there are so many resources, people oftentimes say, oh, like I'll just build my own RAG, and then realize that, oh, why is it so crappy? Like I'm only getting like 80% accuracy. It's because like, yes, like building a POC is easy with anything, but like getting to like the 99%, you're gonna require a lot more effort than just basic vanilla RAG. Yes.
Along the line of inference cost, I think the example you gave a few minutes ago is that the software companies make about 60 to 90% profit versus now AI companies, it's around 40%. And I think a major reason behind that is each time an AI software is used, it costs some money. So that's the inference cost. What would you say or how much would you say the training and inference cost needs to go down, so that after a little bit of premium, the AI business would make sense?
So I stress the importance of using smaller, faster, more efficient models multiple times, primarily because like for us, at the cost that we're providing, like right now, we are already looking at like 85% software margin, profit margins, because we're not using very large, clunky models. We did some benchmarking versus like GPT-4 based implementations and other third-party software. Like our stuff is generally like 3 to 10 times faster when generating a response. And as I mentioned, it's like for us, like it's less than 10% of the cost. And so it is still possible to have a good profit margin. It's just that when it comes to many of the companies building in this field, because they have not done anything with the models on the model level, they just are taking an existing API and using it. And that's one of the reasons why their margins are so bad. But I think a lot of companies, so there are also a lot of resources available now, even compared to last year. So last year, like around like March, we open sourced a library that we named Xturing, which is a open source fine tuning library. And back then there weren't that many like fine tuning resources, but a year later, like today, I think fine tuning has also gotten relatively easier. So we are starting to see some companies that are now taking some of these like high performing, Llama, Mistral type of open source models and fine tuning it for their particular application that are giving them really great results, like better results than GPT-4 or, any other APIs. So ours also, like on average, we have like 30% of, improvement over the GPT-4 APIs. And I think the trend is going to continue where, most of the application will be doable and, with the smaller open source model based implementations, whereas I think the larger models would eventually be handling maybe more complex problems that are okay to be expensive, right? So.
Thank you so much. Thanks to everyone joining online. Have a good one. Bye.